Hi, this is chapter 3, the enhanced entity relationship model. In this chapter, we're going to study several terminology. Also, we're going to study supertype, subtype relationship. And then we will study specialization and generalization technique. Also, we're going to study completeness and jointness constraint. And also, we're going to study supertype, subtype hierarchy for business situation. And then we're going to study entity cluster. Also, we're going to study universal data model, packaged data model. And also, we're going to study special feature of data modeling project using packaged data model. Supertype and subtype. Enhanced entity relationship model extend original entity relationship model with new modeling constraint. Subtype of subgrouping of the entity in an entity type that has attributes distinct from those in other subgroupings. Subtype, a generic entity type that has a relationship with one or more subtypes. Supertype, a generic entity type that has a relationship with one or more subtypes. Attribute inheritance. Subtype entity inherit value of all attribute and relationship of the supertype. An instance of subtype is also an instance of the supertype. The idea of supertype, subtype, and inheritance, which are central to the enhanced entity relationship model, are also key concepts in object-oriented software design and programming. If you ever use an object-oriented programming language like Java or C++, you will encounter the concept of classes, which are similar to types. These classes are arranged in hierarchy, which enable inheritance. The difference between object-oriented programming and enhanced entity relationship, supertype, subtype, is that in object-oriented programming, there is also the concept of behavior object, not only have attribute which can be inherited, but they also have method which implement active behavior. Figure 3-1, basic notation for supertype, subtype notation, enhanced entity relationship notation. This is only one possible notation for enhanced entity relationship. In other figure, we will see Microsoft Visual notation, which is similar but not identical. So there are supertype, so general entity type, and then there are subtype 1, 2, blah, blah, blah. So relationship in which all instances participate supertype, also relationship in which only one specialized version participate, also the other specialized version of supertype is the subtype 2. And then B, Microsoft Visual notation. Also, there are supertype and then another version of supertype, subtype 1, and the other version of supertype, subtype 2. Figures 3-2, employee supertype is 3 subtype. All employee subtype will have employee number, name, address, and date hired. And then there are several subtype, hourly employee, salaried employee, consultant. So each employee subtype will also have supertypes attribute and then their own attribute, hourly rate, annual salary, stock option, contract number, billing rate. It makes sense to model supertype and subtype if certain attribute or relationship apply only to a subset of the total entity type, whereas other are shared across the entire entity's type. In this case, all employees have names, address, and hire date, but only hourly employee have hourly rate, only salaried employee have salary and stock option, and only consultant have contract number and billing rate. If we simply had an employee entity, then these special purpose attribute would be irrelevant for many of the employee. Relationship and subtype. Relationship and supertype label indicate that all subtype will participate in the relationship. The instances of a subtype may participate in a relationship unique to that subtype. In this situation, the relationship is shown at the subtype level. Figure 3-3, supertype-subtype relationship in a hospital. There are patients, and then they have attribute patient ID, patient name, admit date, and also there are responsible physician ID. So relationship for all type of patient is related to is cared for relationship. And that there are two types of patient. One is outpatient, the other one is resident patient. So they all have the patient ID, patient name, admit date, also their own attribute, check back date, and then date discharge it. And also the resident patient related to is assigned to relationship. This is good example of distinction between shared attribute relationship and specialized attribute relationship. So it makes sense to break patient into two subtypes. Generalization and specialization. Generalization, the process of defining a more general entity type from a set of more specialized entity types, bottom up, and specialization, the process of defining one or more subtype of the supertype and forming supertype-subtype relationship, top down. Figure 3-4, example of generalization. Three entity type, car, truck, and motorcycle. All these types of vehicle have common attribute. There are car has vehicle ID, price, engine displacement, vehicle name, make, model, and number of passenger. Also truck have same attribute, and then capacity and cab type. And motorcycle have same attribute from vehicle ID to the vehicle name. So car has its own attribute, number of passenger. Truck has its own attribute, capacity, and cab type. And motorcycle don't have any its own attribute. Sometime during the conceptual modeling process, we begin to recognize common theme among several entity types. For instance, they may all share many of the same attributes, such as previous example, car, truck, and motorcycle all have price, engine displacement, and place, make, and model. Figure 3-4, example of generalization. Generalization to vehicle type. We put the shared attribute in a supertype, no subtype for motorcycle since it has no unique attribute. So vehicle, and then their own attribute. Car has number of passenger, truck has capacity and cab type. So when this happens, we can create a supertype and place the share attribute in the supertype entity. This process is called generalization. The specialized attribute go into subtype entity. In the case of the motorcycle, there is no unique attribute, so there is no need for a specific motorcycle entity. Actually, it may be useful to have an indication that a vehicle is in fact a motorcycle. Later, we will discuss the concept of a subtype discriminator, which is a special attribute at the supertype level that identifies the specific subtype. Figure 3-5, example of specialization, A entity type part. Note, routing number only apply if part is manufactured in-house. Supplier only applies if part is purchased from a supplier. Part number description, quantity on hand, location, routing number, and parenthesis supplier, and parenthesis supplier ID, unit price, parenthesis. Sometimes during conceptual modeling, we discover that certain attribute or relationship apply only to subset of the entities in a given entity type. In this example, we have a manufacturing firm that may manufacture some of its own part and purchase others. If the part is manufactured by the firm itself, it has a routing number, but if purchased, it does not. If purchased, it comes from a supplier, but if manufactured, it does not. Figure 3-5, example of specialization. V, specialization to manufacture part and purchased part. Multi-value composite attribute replaced by associative entity relationship to another entity. So you can see there are part and part number, description, location, quantity on hand, and manufactured part. There are routing number and purchase part. So there are supplier, a supplier ID, and supplies, unit, price. So there are entity type, attribute, and relationship associated with only purchase part. When you find a situation like this, it makes sense to specialization. In this case, we create two subtypes of part, one for manufactured part and one per purchase part. All parts have part number, description, location, and quantity, but only manufactured part have routing number, and only purchase part have supplier. Note that, like the previous slide, the concept of supplier is now represented as a separate entity, and an associative entity represents a many-to-many relationship between purchase part and supplier, with unit price being an attribute of the associative entity. This provides information that was not explicit in the previous slide. A multi-value attribute does not explicitly describe a many-to-many relationship. It could also convey a one-to-many relationship, but when you represent the supplier as a separate entity, you can explicitly show the cardinality of the relationship. For an example of a multi-value attribute that imply a one-to-many relationship, refer to figure 2.19 from chapter 2. Here we have timestamp of price history change. For a given product, there may be many price history items, but each price history item belong to only one product. That's different from what we have here with part and supplier, where a part can have many suppliers and the supplier could supply only part. Constraint in supertype-subtype relationship. Completeness constraint. Whether an instance of a supertype, a subtype must a supertype must also be a member of at least one subtype. Total specialization rule, yes, double line. Partial specialization rule, no, single line. So there are two types of constraint in supertype-subtype relationship. One is called the completeness constraint and indicate whether there must be an explicit subtype for each possible instance of the supertype. The other is called the disjointness constraint, which indicate whether a particular instance of a supertype could also be more than one or one of the subtype. Figure 3-6, example of completeness constraint. Total specialization rule. You can see patient ID, patient name, and admit the same entity, and then there are double line. Total specialization, which means a patient has to be either an outpatient or resident patient. So in this case, a patient must either be an outpatient or a resident patient. There is no other possibility. This particular completeness constraint is called total specialization and is represented by double line coming down from the supertype entity type. And the next slide, figure 3-6, example of completeness constraint, B partial specialization rule. There are vehicle and the same vehicle entity, and there are single line. So partial specialization, which means a vehicle can be a car or a truck, but does not have to be either. So we already saw this example from earlier. This is partial specialization because some vehicle are motorcycle, which is not exactly represented as a subtype entity. So going back to figure 3-5, do you think the division of part into manufactured versus purchased part imply total specialization or partial specialization? Probably total specialization. Either a part is manufactured in-house or purchased from an external supplier. There is probably no other possibility option. Constraint in supertype-subtype relationship. Disjoint constraint. Whether an instance of a supertype may simultaneously be a member of two or more subtypes. Disjoint rule. An instance of the supertype can be only one of the subtype. Overlap rule. An instance of the supertype could be more than one of the subtypes. There are two types of constraint in supertype-subtype relationship. One is called the completeness constraint and indicate whether there must be an explicit subtype for each possible instance of the supertype. The other is called the disjointness constraint, which indicate whether a particular instance of a supertype could also be more than one of the subtype. So we can have four possibility: total specialization with disjoint, total specialization with overlap, partial specialization with disjoint, partial specialization with overlap. Figure 3-7, example of disjoint constraint, disjoint rule. Also same slide. So there are, you can see, disjoint rule, D. A patient can be, total specialization and then disjoint rule, which means a patient can be either an outpatient or a resident patient, but not both at the same time. Here we see a disjoint rule, not overlap. Rule regarding patient. A patient can be both a resident and an outpatient, at least not at the same time. Of course, it's possible for a patient to be a resident for a period of time and then change to an outpatient or vice versa, but the patient cannot be both simultaneously. Figures 3-7 or the overlap rule. You can see the part and all. The overlap rule, a part may be both the manufactured part and purchased part at the same time, but it must be one or more or the other due to total specialization. Double line. So here on overlap rule, some kinds of part could be manufactured in-house and also purchased from external supplier. Note that total specialization rule, which we discussed earlier slide. And subtype discriminator, an attribute of the supertype whose value determine the target subtype. Disjoint, a simple attribute with alternative value to indicate the possible subtype. Overlapping, a composite attribute whose subpart pertain to different subtypes. Each subpart contains a Boolean value to indicate whether or not the instance belongs to the associated subtype. Figure 3-8, introducing a subtype discriminator, disjoint rule. Employee, employee number, employee name, address, date hired, employee type, subtype discriminator with value of H, S, or C for disjoint subtype. So you can see, there are D, so hourly employee, and then salaried employee and consultant. You can see hourly means H, salaried means S, consultant means C. Here for the disjoint rule, we have employee type as the subtype discriminator, and it can have 3 possible values, one for each subtype. Going back to previous slide, figure 3-7, what would be a possible subtype discriminator and what would its value be? And figures 3-9, subtype discriminator, overlap rule. You can see there are part and then manufactured part, purchased part. So subtype discriminator is a composite attribute when there is an overlap rule. So part type, there are manufactured Y, yes, purchased Y, yes. So note that the required for a composite subtype discriminator here. So there are 3 possible scenarios. Number 1, manufactured yes and purchased yet. Number 2, manufactured yet and purchased no. Number 3, manufactured no and purchased no. Note that it is impossible for this scenario to occur, manufactured no and purchased no. Why is this not possible? Because of the total specialization rule, at least one of these have to be yes, why? Figure 3-10, example of supertype subtype hierarchy. There are person and social security number, name, address, gender, date of birth, attribute, and then total specialization double line, and also overlap blue. And there are, you can see employee, alumni, student, employee have salary, date hire, alumni, degree, year, uh, designation, date, and student, major, department, and disjoint rule, also disjoint rule, and total specialization. You can see there are employee can be faculty and staff. Faculty has attribute length, staff have position, and then student, also graduate student, undergraduate student. So there are test score attribute and class standing attribute. So supertype subtype hierarchy can be as deep as we want them to be. Here we see the faculty is a type of employee, which is a type of person. Note here that a person must be either an employee, alumni, or student. Is it possible for a person to be both an employee and a student? Why or why not? Yes, because of the overlap law. Can you envision what the person's subtype discriminator would be? It has to be composite attribute. It is possible for an employee to be something other than faculty or staff. Why or why not? Yes, because of partial specialization. Is it possible for an employee to be both faculty and staff? No, because of disjoint rule, not overlap law on the employee. Is it possible for a staff member to also be a graduate student? Yes, because of the overlap law on the person. Is it possible for someone to have more than one degree from this university? Yes, because degree is a multi-value attribute. Entity cluster and enhanced entity relationship diagram are difficult to read when there are too many entity and relationship. The solution is group entity and relationships into entity cluster. So entity cluster is set of one or more entity types and associated relationships grouped into a single abstract entity type. Figure 3-13 entity cluster for Fine Valley Furniture Company. So possible entity cluster using Microsoft Visual related group of entity could become cluster like this, like this, and like this, like this, and like this, and like this. So you can see next slide. Enhanced entity relationship diagram for entity cluster. It must be more readable. So we clustered these 22 entity into 8 cluster. The relationship between cluster occur if there are relationship between entity within the individual cluster. For example, since there is a one-to-many relationship between the customer entity and the other entity, this implies a one-to-many relationship between the customer cluster and the item sale cluster. Note that the associate entity often stand apart from the cluster and provide linkage between them. Figures 3-13 entity cluster for Fine Valley Furniture Company. So details for single cluster. So You can imagine the entity cluster diagram to be a bird's eye view model. The model can then drill down to see detailed view of individual cluster. Packaged data model. Predefined data model. It could be universal or industry specific. Universal data model or generic or template data model that can be reused as your starting point for data modeling project, also called pattern. There are several advantages of packaged data model. Use proven model component, save time and cost, less likelihood of data model error, easier to evolve and modify over time. Aiding requirement determination, easier to lead, supertype subtype hierarchy, promote reuse. Many-to-many relationship enhance model flexibility. Vendor supplied data model foster integration with vendors application and universal model support into organizational system. So figure 3-15 party role and role type in a universal data model. A basic party universal data model. Package data model are generic model that can be customized a particular organization business rule. So attribute of all type of party role, and there must be a starting date from date when a party start to serve in a party role for a certain role type. And a person has name but may have a different name when acting in a person role. Override the attribute of same name in the entity person role higher in the hierarchy. What then do package or universal data model look like? Central to the universal data model approach are supertype subtype hierarchy. For example, a core structure of any universal data model is the entity type party, which generalizes person or organization as actor for the enterprise, and an associated entity type party role, which generalizes various role party can play at different time. A party role instance is a situation in which a party acts in a particular role type. These notions of party role, and role type, supertypes, and their relationship are shown in figure 3-15a. We use the supertype subtype notation from figure 3-1c because this is the notation most frequently used in publicly available universal data model. Most package data model are proprietary intellectual property of the vendor, and hence we cannot show them in this slide. This is very generic data model. This type of structure allows specific party to serve in different role during different time period. It allows attribute value of party to be overridden, if necessary, in the organization by value pertinent to the role being played during the given time period. Example, although a person of the party's supertype has a current last name as of now, when in the party role of bill to customer, a different current last name could apply during the particular time period, from date to through date of that role. Note that even for this simple situation, the data model is trying to capture the most general circumstances. For example, an instance of the employee, subtype of the person role, subtype of party role would be associated with an instance of the party role type that describe the employee person role type, party role. Thus, one description of the role type explain all the instances of the associated party role of that role type. In figure 3-15, V party supertype subtype hierarchy. An interesting aspect of figure 3-15a is the party role actually simplify what could be a more extensive set of subtype of party. Figure 3-15b show one party subtype with many subtype covering many party role. With partial specialization and overlap of subtype, this alternative would appear to accomplish the same data modeling semantics as figure 3-15a. However, figure 3-15a recognizes the importance modeling semantic as figure 3-15a. However, figure 3-15a recognizes the important direction distinction between enterprise actor parties and the role each play from time to time party role. Such the party role concept actually add to the generalization of the data model and the universal applicability of the predefined data type model. So you can see there are party ID, and then person, and then organization. Yeah. So this is the final slide. Let's call it a day. Yeah. See you next time. Bye.